Hello, good morning, students. Let's try to understand, students, packing of particles in crystals. Okay, lattice. So, crystal lattice, student, different type of unit cell you already studied, and in which you find that is the particles are in the simple cubic, there are on the corners, and in the BCC there is one particle in the body center as well as all are the corners, and face center all the particles are there on the face along with the corner. So what we are going to do, that is how much percentage is here is completely occupied, student, that we have to find out, that how much percentage of the unit cell is completely covered by the atoms. So let's have, students, that is constituent particle of a crystalline solid are closed pack. So in the constituent particles means what, student? If you talk about constituent particle, what they can be? They can be atoms, or they can be ions, or they can be molecules. So these are what, student? These are, they are saying closed pack. They are the closed pack. Now, while describing the packing of particles in the crystal, the individual particle are treated as the hard sphere. Okay, so where atoms are there or the individual particles, ions are there, they are treating as a hard sphere, means spherical. The closeness of particle maximize the interparticle attraction. So why they are being closed? Because of the interparticles attractions are there, that you have to keep in mind, students. So first point you are taking care, that is constituent particle of crystalline solid are the closely packed. While describing the packing of particles in a crystal, the individual particle are treated as hard sphere. And lastly, the closeness of particle is maximized the interparticle attraction. Okay, that's point. Now they are saying the number of neighboring spheres that touch any given sphere is its coordination number. Again, the point you can keep in mind, the number of neighboring spheres that touch any given spheres in its coordination number. The number of neighboring spheres that touch any given spheres is its coordination number. Means suppose if it is this a coordinate, this is a atom A is given, and that is two atoms are touching both the side, so coordination number is 2. And if you are having this one A, and if the four atoms are touching this one like that, okay, this is how many atoms are touching? 6 atoms are touching, so that is coordination number is how much are there? 6. Okay, let's have a look next point. Magnitude of the coordination number is measures of the compactness. See the point, student, what the point are there. Magnitude of coordination number is measure compactness of the spheres in closed packed structure. Dear students, please keep in mind what they are saying. Magnitude of the coordination number is measure the compactness of the spheres in the closeness of structures. Okay, the larger the coordination number, the closer are the sphere to each other. The larger the coordination number, the closer are the sphere to each other. That's keep in mind, student. Okay, let's have a look over, students, this point. First, closed pack structure, what we are talking. The three-dimensional closed pack structure can be understood conveniently by looking at the closed packing in one and two dimension. In one and two dimension. Dear students, here you can keep in mind they are saying the three-dimension closed pack structure. The three-dimension closed pack structure can be understood conveniently by looking at the closed packing in the one and two dimension. Okay, so firstly we have to know the idea of the closed packing in one and closed packing in two dimension. Okay, then only the three dimensional closed pack structure can be understood. Okay, so if you know very well one dimension, two dimension, then third three dimension is possible. So now the very first point, closed packing in one dimension. A closed pack in one dimension is the structures result by arranging the sphere to touch each other in a row. So how they are arranging, student? It is the closed pack in one dimension. This is going to be arranged in the linear manner, student. Okay, linear manner. See, a closed pack structure one dimension is resulted by arranging the sphere to touch each other in a row. So they are touching in each other. This is all are touching to each other. So coordination number is here is 2. This is the close packing in one dimension. Now close packing in two dimension. Let's have a look over close packing in two dimension. Close packing in two dimension. Close packing in two dimension. They are saying, student, a close packed two dimension planar structure resulted by stacking the rods together such that they are contact with each other. There are two ways to obtain the close packing in two dimension. First one is square close packing. So square close packing means one dimensional row of the close packed sphere are stacked over each other such that the sphere align vertically and horizontally. If the first row is labeled as A type, being exactly the same as the first row, the second row is also labeled as A type, hence the arrangement called A type two-dimensional arrangement. In this arrangement, every sphere touches four neighboring atom sphere, hence the two-dimensional coordination number here is 4. A square is obtained by joining the entire of these four closest neighbor. Therefore, the two-dimension closed packed square is called square closed packed in two dimension. So here they are saying this is the arrangement are there, that is they are the exactly the one row is the equal to second row. First row is equal to second row. So if you are naming the first row is A, so this is again will be A, this is A, this is A. So all are the A are there. Okay, this is what. So that is what, if you are talking about any of the atom, you can select it out. So what is happening here? Four atoms are touching together. Four atoms are touching together. So this is something what is known as square close packing. Now let's have a look over the what is the next one, hexagonal close packing. If you talk about the hexagonal close packing, so close pack one dimension row shows that there are the depression between the neighboring sphere. Okay, if the second row is arranged in such a way that its sphere fit in the depression of the first row, a staggered arrangement results. If the first row is called A type, the second row being different is called B type. Placing the third row in staggered manner in a contact with second row give rise to an arrangement which is sphere in the third row are the aligned with the sphere in the first row. Hence the third row is A type. Similarly, sphere in the fourth row will be the aligned with the sphere in the second row, and hence the fourth row would be B type. The resulting two-dimensional arrangement is AB type. In this arrangement, each sphere touches 6 closest neighbor such that two-dimensional coordination number in packing is 6. A regular hexagon is obtained by joining the sphere of these 6 closest sphere. Hence this type of two-dimensional close packing is called hexagonal close packing in two dimension. Compared to the square close packing in two dimension, the coordination number of hexagonal close packing in two dimension higher. Moreover, the free space arrangement in less in square packing, making it more efficient packing than the square packing. Hence, it is evident that the free spaces void are the triangular in shape. These triangular voids of two types. Apex of the triangular void in alternate row point upward and downward. Okay. So close packing in one dimension, square close packing, hexagon package in two dimension. So this is the linear arrangement. It is means one dimension. This is what student close packing in one dimension. This is close packing in what student one dimension. And here you can see the coordination number is how much? 2. Here touching any atom is touching here. Now next one is square close packing. Dear student, this is the square close packing. So A is being touched by 4 atoms. So coordination number is 4. Here is A is being touched by 6 atoms. So coordination number is 6. So this is what the answer. Now stacking up is square close packed layer. Is stacking up square closed packed layer. This is what the point is. Stacking up square closed packed layer, right? So is stacking up square closed packed layer generate the three-dimensional simple cubic structure. Here the second layer is placed over the first layer so as to have the sphere exactly above those of the first layer. Okay, subsequent square closed pack layer are the placed one over the other in the same manner. In this arrangement, sphere of all the layers are perfectly aligned horizontal as well as the vertical, hence all the layers are alike and labeled as A. This arrangement layer is described as A type. Okay, a structure that result in stacking square closed pack layer in a simple cube. It's called primitive cubic unit cell. Okay, so this is what something you got, student, in the corner atom. You got that is primitive unit cell, student. This is the primitive unit. So this is what the structure. So stacking up square closed square, stacking up square closed pack layer. It can be seen that the simple cubic structure, each sphere touches 6 neighboring spheres, 4 in its own layer, 1 in the layers above and 1 in the layers below. Hence coordination number of each sphere is 6. Polonium is the only metal that crystallizes in simple cubic closed pack structure. Okay, here dear students, here you see. Okay, it can be seen that in the simple cubic structure, each sphere touches 6 neighboring spheres, 4 in its own layer, 1 in its layer above and 1 in its layer below. Hence the coordination number of each sphere is 6. Polonium is only metal that crystallizes in the simple cubic closed packed structure. Is stacking up two hexagonal closed pack layer. To generate closed pack in three-dimensional structure, hexagonal closed pack layer are arranged in the particular manner. In doing so, a sphere of second layer are placed in the depression of the first layer. In the first layer is labeled as A layer and second layer is labeled as B layer because the two layers are aligned differently. It's evident from the figure 1.5 that all triangular void of the first layer are not covered by the sphere of the second layer. The triangular void that are covered by the sphere of the second layer generate the tetrahedral void. A triangular void is surrounded by 4 spheres, and joining the center of these 4 spheres, a tetrahedron is formed which encloses the tetrahedral void. The remaining triangular void, the first layer, have above then in triangular void of the second layer. The overlapping triangular void from them, 2 layers together from an octahedral void, which is surrounded by 6 layers. So here are the, okay, you are firstly covering 2 layer closed packed structure. Okay, then what they are saying, that is there is triangular void are there and then you are placing, so you are getting tetrahedral void. Okay, now we are going to cover that one, so you are going to get, after covering this, you are going to get the octahedral void. Okay, placing the third hexagonal closed packed layer. There are 2 ways of placing the third hexagonal closed pack layer on the second way. They are saying there are 2 ways of placing the third hexagonal closed packed layer on the second. They are saying one way of doing this to align the sphere of the third layer with the sphere of the first layer. The resulting pattern layer will be, that is ABAB. This arrangement is called hexagonal closed packing structure. Metals such as magnesium, zinc have the SCP structure. Second one, the second way, the placing the third hexagonal closed pack layer on the second is to cover the octahedral void by the sphere of the third layer. In such placing, the sphere of the third layer do not align with the sphere of the second layer sphere. The first layer, the third layer sphere called the C layer. The sphere of the fourth layer get aligned with the sphere of the first layer. Hence the fourth layer is called A. This pattern is taking closed pack is called ABC, that is in the cubic closed pack structure. This same FCC structure, metals such as copper, Ag, crystals have this type of structure. Expanded view is like that. So this is all about the closed packing structure in the solids. Thank you so much for watching, friend. If you find this video helpful, please do like and subscribe the channel.